Hello, Legacy Sabers. Marsh here. So today we're going to talk about even and odd functions. What you're going to want to have on you today is your notes and a pen or a pencil to take those said notes. Today, the learning target, which you're going to want to put at the top of your page, is the following. I can identify an even or odd function using a graph or algebraically. So technically there's two learning targets kind of wrapped it but into one another. Now, what I hear you thinking is, Marsh, well, what do you mean by even or odd? Like, are we talking like 1 and 2, like that kind of even odd? Actually, we're talking about symmetry. Different functions have different kinds of symmetry. Now, if you remember back from geometry, what it meant to have symmetry was meaning that stuff would fold perfectly in half, right? Basically, it was a mirror image around that area. Well, we will say that even functions have y-axis symmetry. So right here, I'm going to draw my graph here. This graph has y-axis symmetry because those two sides, if you look at them, if I fold along that y-axis, the dotted line, they will perfectly line up to one another. Another way that we can identify y-axis symmetry is we can say for every even function, that every point xy on the graph, that point negative xy is also on the graph. That's the mathematical way of saying it. What they're saying is if I have the dot 2, 3 on my graph, I'm also going to have the dot negative 2, 3, which makes sense, right? Because if I have 2, 3 and I'm folding over the y, the x's are going to be opposites of one another, correct? That's how that is working out there. We're going to say odd functions now have origin symmetry. And this is kind of a little bit funky. Origin symmetry is when you have symmetry over y equals x. So that's this line right here. Okay. Here is how I identify origin symmetry by my eye. I fold over the x, and then I fold over the y. Otherwise, it's kind of hard to see. So I'm going to fold the X and then I'm going to fold the Y. See how it would line up? This guy, so if I fold over the Y first, we're going to get something that looks like this. It's going to be kind of not the best drawing, I'm going to be honest. So there would be something like that. And then when I fold it over the X, then it would perfectly line up. The mathematical way to say this, however, is for an odd function, we're going to say if we have xy, we also have negative x, negative y, which makes sense when we're looking at it, right? Because if I'm folding over the x and folding over the y, you are actually changing both the x and the y signs. You're going to get both negative and negative for both of your coordinates. Now you're probably thinking, hey Marsh, so we're talked about y symmetry. We also talked about origin symmetry. What about x-axis symmetry? Is that even a thing? Like, is that like some other word than even and odd? The answer is no. X-axis symmetry is not a function. Because remember that vertical line test that we talked about long, long ago, you learned about it in Algebra 1, in which if I can graph a line, a vertical line, and I touch a function twice on that line, you do not have a function. And we're only talking about even and odd functions today. So x-axis symmetry is not something we're focused on today. A function, now let's say if we want to look at algebraically, because sometimes we don't want to graph everything. A function is even if f of negative x is equal to f of x for every number of x in the domain. This is the math part, the stuff that's in the box here. Here's the literal translation, the TLDR. Too long, didn't read, right? Plug a negative x into the function. You're going to substitute negative x into the function. And if you get the original function, no changes in signs, you're going to be able to say that that graph and that function is in fact an even function. Let's try it. So I have this graph right here. F of x equals 5x to the fourth minus 2x squared plus 1. Let's substitute a negative x in for my x. So I'm going to say 5 negative x to the fourth minus 2 negative x squared plus 1. Now, we got to do a little bit of a conversation over here. If I have negative x to the fourth, that would mean that I have negative x times itself 4 times, right? That's what a to the fourth power means, right? Well, a negative x times a negative x would be a positive, and a negative x times a negative x would be a positive, and a positive times a positive is a positive, right? So would you agree with me that negative x to the fourth, that would just be an x to the fourth, right? This negative, I technically have 4 negatives, and they're going to cancel each other out, right? So we could just rewrite this, simplify this as 5x to the fourth. Same thing could happen to negative x squared, right? That's 2 negatives. Those 2 negatives are going to multiply one another, and we're just going to get an x. So we still have this negative 2x squared plus 1. That nothing happened there. This guy right here, let's check. Is it the same? I want to see. Is it the same? We're talking same signs. We're talking same numbers. We're talking same everything. That matches. Yep, they are the same. So this is, in fact, an even function. And here is its graph. Notice that y-axis symmetry. Isn't that kind of cool when the algebra and the graph actually are the same? You can actually prove it both ways. But sometimes we don't have the graph, so we got to be able to do it algebraically as well. Let's try another function. So I have 2x to the third minus x. Again, we're trying to identify an even function. So we're going to substitute a negative x in. So I'm going to go 2 and then to the negative x cubed minus and then negative x. Now, let's discuss again. Negative x cubed. We would have 3 negatives, right? The negative isn't going to cancel out. Right? They're not going to all go away. So what's going to happen is we're going to take that negative and we're going to tack it onto the 2. So negative x cubed is going to leave us as a negative x cubed. So I'm just going to take the negative and put it with the 2. Otherwise, I'm going to lose it. So I'm going to put it in front of the 2. Negative times a negative right here. We're subtracting a negative. You're going to have positive. So we're going to get positive x going on there. So let's take a look. Not the same, right? Definitely not matching. So this is a not even. Let's take a look at the graph here. Yep, no y-axis symmetry, right? Nothing happening there. So this is definitely not an even function. But you're probably like, well, Marsh, look at that graph. Isn't that odd? Because it's origin symmetry, right? You're right. That one actually is an odd function. So how do we know if it's odd? What we're going to say in the mathematical is we're going to say if f of negative x is equal to negative f of x for every number of x in the domain. That was a lot, right? Let's simplify it. Simple English. So if I plug a negative x into the function, substitute a negative x in the function, and you get the negative of the function back again. All terms have changed signs. You have an odd function, okay? So instead of even where no one changed, you now need to be odd. You need everybody to change their sign. If one person doesn't, sorry, it's got to be everybody. So let's take a look at the one that we just looked at. I'm going to plug in a negative x. I'm going to substitute a negative x in. Right here. Negative x cubed. Again, that does not simplify, right? Because you have an odd number of negatives in there. So we're going to have negative x cubed. Well, that negative is not going to cancel out, so I'm going to multiply that negative 1, because, right, there's technically a negative 1 right here. 3 times negative 1, and we're going to get negative 3x. Oh, silly Marsh, you missed the negative in the front. Whew, that could have been bad. Okay, well, then we would have had a negative, so that's actually a positive x cubed. Look, the signs have completely changed. Positive x cubed and a negative 3. That completely changed. This is an odd function. Now, looking at its graph, see how it is origin symmetry. Remember origin, the way we are going to check it is we're going to fold over the y and we're going to fold over the x. So this hump would have gone right here, and then it's going to fold over, and then it'll match perfectly for us. Let's try one more here. So again, we're going to substitute that negative x in. So I'm going to do a negative. There we go. Negative x cubed. Again, odd number of negatives, so that negative is going to hang around. So we're just going to tack it in front of the 3 there. This negative and that negative, they're just going to become a positive, right? Because we're multiplying negative 3 by a negative 1. And I got that negative 3. So let's check. Okay, perfect. We swapped signs. And we swapped signs. Didn't swap signs on the last one, right? So this one is not odd. It's also not even because not everyone stayed the same. And if we look at our graph, yeah, there's definitely not y-axis symmetry. There's definitely not origin symmetry either. So now what happens if that, do you just not get to say even or odd? Is there a different word for it? If a function is not even or odd, we just say it's neither, meaning it's neither even or odd. Okay? So let's determine if the following functions are even, odd, or neither. Let's plug in, substitute that negative x. So negative x cubed minus 1. Again, odd exponents. So that means they're going to swap that negative, right? That negative is going to stay with us. Let's check. Did it stay the same? No. Did everyone swap? Change their sign? No. This guy is neither. Can't say anybody. Let's check this one. So I got negative 3, caught that time. Negative x to the 4th minus negative x squared plus 2. Just substitute in that negative x in to check to see what happens. Negative x to the 4th. Well, you're going to have an even number of negatives. So that negative is technically going to disappear, right? So we're going to have 3x to the 4th. Negative x squared. Negative x times a negative x is just x squared, right? So that negative, this negative is still there, but this negative is going to actually disappear. I got plus 2. So now let's check. Did everyone stay the same? Yes. So this is an even function. Now, notice you can't be even and odd. That's not possible. It can either be even, you can either be odd, or it can be neither even or odd. And that is the end of this video. I know that we're going to get a couple more questions because there's some strange things that can happen with even or odd, especially what kind of functions that you see. But until then, I will see you later, Sabers.